6.1, Part 2, Example 3 here says solve the right triangle ABC if angle A is 23 degrees and side C is 5.8. So what I'm going to do here is I'm going to set up what I call like a little answer block. So I have angles A, B, and C in here. And then I have sides A, B, and C. Because it said to solve the right triangle. So once I have all of these answered, I am completely done with this problem. So now let's plug in what they gave us. They gave us angle A, and they gave us side C. Now, they leave us to assume, what they didn't draw on here, is that we're looking at the triangle like we looked at above. And so I'm going to draw it right here at the very top. So it's going to look like this, and this is going to be angle A, angle B, angle C. It's going to be our 90 degrees, and these are going to be our sides, okay? So I can go ahead and fill in then that angle C is 90 degrees. And so we're just going to go through and we're going to find our missing pieces. So the first thing is, let's find angle B. That's usually what y'all like to find first, especially since you know the other two angles. So you know that there's 180 degrees in the triangle, so we're going to subtract out the two that we know added together. And that's going to give us angle B is 67 degrees. Now, we really only want to use what was given to us if possible. If I use angle B to solve something and I missed angle B, I'm going to miss everything I use to solve with it as well. So, when I go to look for side A, if you need to, label it on your triangle so you can see it. I'm going to actually, I'm going to just label it the triangle at the top, and then I'll erase it. So we know that angle A is 23 degrees. We said angle B is 67 degrees. Side A we don't know, side B we don't know, and side C is 5.8. So, but remember, angle A was given. So if I'm looking for side A, that's going to be opposite, and side C was given, which is hypotenuse. So in order to find side A, if I'm looking for the opposite and I know hypotenuse, that's going to be our sine function. So we know the sine of angle A is going to be the opposite, which is side A, over the hypotenuse, which is side C. And so sine of 23 degrees will equal side A that we're after over the 5.8, which is side C. And then we're just going to multiply both sides by the 5.8 to get rid of the fraction. And so we get the side A is equal to 5.8 times sine of 23 degrees. We're going to make sure we're in degree mode in our calculator before we type that in. And we should get 2.266 approximately. So I'm going to go ahead and just round this to, I'll leave it at 3. That's not bad. So it's 2.266. And if they gave us units, we would need to make sure we wrote our units there. Alright, so then let's go find side B. Now remember, if I use angle B and it's wrong, then I'm going to miss side B as well. So I'm going to try not to use it. But look, I was given angle A, and I know side B is the adjacent, and they gave me side C, which is the hypotenuse. So I can actually use cosine of angle A, which would be the adjacent over the hypotenuse, to be able to solve for side B. And so cosine of that 23 degrees is equal to side B, which we don't know, over side C, which is the 5.8. And again, let's multiply by 5.8 to get rid of that fraction. And so we know side B is equal to 5.8 times cosine of 23 degrees. And so we're going to type this in our calculator to get an approximate answer. And I got 5.339. And like I said, there's other ways we could do it. We could have used the 67 degrees. We could have also used Pythagorean theorem. Could have used a squared plus b squared equals c squared there. But because I wasn't given a, if my a is incorrect and I use Pythagorean theorem, then I'm going to miss B as well. And I really don't want to have a double whammy there. And so I have answered all my angles, all my sides. So I have solved the right triangle.